Or it's because of more energy causing more
It's gonna be faster. Do you think that the number of particles from the products, they will be higher or lower?
higher.
Higher, right? The chemical reaction will speed up, right? So what about if we add more atoms, let's say for A? I'm adding A now. I'm increasing the concentration of A. What will happen to the chemical reaction rate?
It will increase.
It will increase. So as you can see, so it will increase.
So are you increasing the pressure?
No, it's increasing concentration.
No, only the concentration. I cannot like control the pressure. So as you can see, whenever I increase the concentration for any of the reactants or increase the temperature, the reaction rate will increase.
So can you control the surface area?
And no, I cannot control the surface area. So let's watch this video. It's going to be a short one. Just to summarize what we have said.
Okay, there are 5 factors. The first one is the total surface area.
This is how AI optimizes my schedule. This meeting got canceled. Hooray! We didn't really want to go. The reactions occurs. So if the rate is high, means that the reaction is fast. That is total surface area. Okay, bigger total surface area, higher rate. The second factors, concentrations of solutions. Okay, the higher the concentration, the higher the rate of reactions. The third factors.
Who can explain the second factor, the concentration? Why when we increase the concentration of one of the reactants, this will make the chemical reaction faster?
Because they're all closer together.
They will be closer together? Yes.
It's just more particles per unit volume, so obviously more successful collision.
Totally right. So it's more particles per unit volume, and this will make like more collision or more successful collision between the
The
reactants.
third factor is the temperature. The higher the temperature, the higher the rate. And the fourth one is the catalyst.
So what about the temperature? Amar, how can you explain the relationship between the temperature and the rate of the reaction?
At higher temperatures, it's faster because the particles are like colliding with each other more.
Why we will collide more?
Because the kinetic energy increases.
That's right. Because increasing the temperature, this will increase the kinetic energy. More particles will have like, let's say, more or equal to the activation energy that the reactants they need to form the products. And what about the catalyst? Yes.
So it lowers the activation energy so that the reaction can take place faster.
That's right.
For positive catalyst, it increases the rate, and for negative catalyst, it reduces the rate. And the last one is pressure. This only affects the reactions that involve gas. And the higher the pressure, the higher the.
Can I explain the last factor here, which is the pressure? This one applies only for gases, by the way. So, Zena?
When the pressure is higher, there's more successful collisions.
Because there's more reactants.
No, because the container is smaller.
The container is smaller, so what does it mean?
So the
That's what-
particles they bump into each other and the walls of the container more, increasing the
Right?
Rate of reaction.
Sorry man, I'm very excited.
So,
Please keep good decorum in the class.
It's not very clear.
exercise possibilities answer these questions. First one, explain the effect of increasing temperature and the rate of reaction in terms of collision theory. Max will Boltzmann ignore this one. I'm going to explain this later.
There's another negative catalyst called an inhibitor. Is it called a negative catalyst or is it an inhibitor? It's called an inhibitor.
Explain the effect of increasing temperature on the rate of reaction.
Please respect the core of the class.
More movement, more successful. Therefore, more movement. Therefore, a higher rate
higher reaction.
So guys, if you'd like to know more about the Maxwell-Boltzmann, yeah. So guys, check page number 2 and 3 in the booklet. Guys, open page 2 and 3 in the booklet.
George, give me a booklet. Give me my booklet. Huh? Oh yes. So this is the Kinetics booklet. It gives you a recap of all the factors that affect the rate of reaction.
Factors affect the rate of reaction, Chase?
Yeah.
Which one?
Temperature, pressure, concentration. شو فيك انت؟ It's temperature, concentration, pressure, catalyst. I'm not going to give you the answer. Huh? Okay.
Energy that enable more particles to react and collide together to form also the products. So here for temperature, we said the food boils more quickly at room temperature than in a refrigerator, as the bacteria grow faster at RT than a lower temperature. So at higher temperature, the reactant molecules, they have more kinetic energy, so they move faster, they collide more, so more successful collisions between the reactants and the greater energy. For the concentration, as the concentration of reactants increases, so does the likelihood that reactant molecules will collide, and then the rate of the chemical reaction will generally increase. In the first container up there, we have fewer particles, and the second one more particles. So which one do you expect, let's say, faster reaction rate? The one up or down? Down, with more concentration of the reactants. The catalyst, it's a substance that increases the chemical reaction without being consumed in the reaction. And this will be explained in detail in the reaction mechanism. So as you can see here, we have two reactions. The reactants here, they react together without a catalyst. This is with a catalyst, and this one without a catalyst. Which one lowers the activation energy? Is it the one with or without? With. So whenever here we have lower activation energy, this means more particles from the reactants. They can overcome the activation energy and form more products. Is that clear?
It's more complex than the last year's Maxwell superb.
Yeah, I know. It's more complex than the last year. And this is the surface area. As you can see, whenever we have like smaller particles, more surface area, this means more contact between the particles to collide, and more or the chemical reaction will speed up. I want you to answer this question in your exercise book. So how can magnesium and hydrochloric acid, they react together to form magnesium chloride and hydrogen? Explain this using the collision theory. Pay attention, this question is out of 4. You need to mention 4 points in your answer.
And that's the end of the recording.